So I'm Paul Coggin. I'm from the U.S., specifically live in Huntsville, Alabama, down in the southeast corner of the U.S. Primarily my experience is network infrastructure, service provider, telecommunications, utilities, both implementing, architecting, and securing the critical network infrastructure, and also the heavy emphasis on penetration testing. And today, for the last 3 years, I'm specifically 100% focused on red teaming. But as you mentioned, I've been reading, like everyone, a lot about the SS7 protocols that are being hacked, and having a telecom background. My experience was always in the data side with just a little bit of voice experience. I primarily just provided transport for the voice services and worked more on the data and the cable TV side of the house or service provider. And I've started thinking, it's like, we were seeing all these publications about SS7 protocol vulnerabilities, and I was like, well, how does someone actually get access to exploit these SS7 vulnerabilities? Because those are typically closed networks and not just intentionally open to the internet. So here's some ideas. If someone was going to go after these networks, how would they get that initial handhold so that they could exploit the protocol vulnerabilities that have been published by a number of organizations here recently? So before we dive into that, let's do an overview of SS7. If you're like me and you're not a Class 5 switch operator, if you're not a voice carrier expert, let's go and jump in and do a quick overview of SS7. So SS7 is basically, think of SS7 as BGP, the Border Gateway Protocol for the internet. Well, SS7 is the equivalent of BGP for the PSTN, the Public Switch Telephone Network. It's how all the different voice networks around the world communicate. And just like we have these open trust relationships with BGP so that we all can communicate across the internet, send email, surf the web, et cetera. Well, SS7, between all the different telco service providers, there's a trust relationship that everybody's doing what they're supposed to be doing and doing due diligence. And we know with like all BGP in the news that not everybody's doing what they're supposed to be doing, right? And this SS7, especially to a lot of people like myself in INFOSEC, it's kind of like a black box. We just trust the voice guys to be doing whatever it is, their magic in making things work. But SS7 has been around. It got created initially like in the 70s by AT&T. Whenever you're making phone calls between your local exchange carriers, your central offices, in whatever, say your regional area, your cities, when a call leaves that local area, it is going to utilize SS7. When you're using your cell phone network and roaming around, all those communications are happening with SS7. SMS is using it, the call blocking, emergency services in the U.S. we call it E911 for dialing emergency services. Caller ID, all those things depend on SS7 protocol. Now, when you start talking about the architecture of SS7, you start talking to voice telecommunications people, you quickly start drowning in a whole new set of acronyms, and a few of those acronyms are referring to the node types. You have what they call signal transport point, and you can think of that as signal transport point, the STP. Think of it as a router for the PSTN, for the SS7. Basically, it's like an SS7 router. It's the way I would, being an old school router person, that's how I think about it. And it also has, not only does it route SS7 messages, it also has some basic filtering capabilities, just like a router has access control list capabilities, some basic filtering, basic firewall capabilities. The STP has some basic filtering capabilities as well built into it. And then you get into what they call the service switching point, the SSP, and that is what they call a Class 5 switch. That is the switch that in the past, it would fill up a room. It would be just rows and rows of equipment that would fill up a room. Maybe your Siemens, Nortel, Lucent, but just rows and rows of equipment. And now it's been consolidated down to a soft switch where it might be just one 21-inch rack with a couple of Sun boxes, a couple of Unix boxes, for redundancy. You can consolidate all that down now. And so it's a soft switch, but it's basically providing what they call Class 5 services, where you can run voice services for a whole city, large geographic area. And that's providing the voice, the fax, the modem capability. dial tone services. And then you get into what they call the service control point, the SCP, and that is the database. It has all the numbers for, say, 800 numbers, and the cellular has, the mobile subscribers, the different calling card services, et cetera. That's all going to be in the service control point, the SCP, which, being a database, that's going to be a target-rich environment to get a hold of. It's going to have some good information in it from a security standpoint. So from an architecture standpoint, when we talk about SS7, here's what we're talking. Like I said, I'm an old school network person, so I want to know how the network's built. Everything for me is about the network. Yeah. So here's what the SS7 network architecture looks like. You have your STPs that in the network, and they're going to be connected to your SCP and your SSPs. We talked about that service control point and that service switch point. They're going to be connected with links. There's a lot of specialized links in SS7, and it's going to connect to those services with A-links, which are basically in Europe and most parts of the world. It's going to be E1s. In the U.S., we use T1s. But when you're talking about SS7, they have specific terminology for the functionality and features that are being provided over those links. So A-links are going to tie in your SCPs and your SSPs back to the STPs. Basically, like I said, they're providing SS7 routing functionality. And down at the bottom, you can see where you got SSPs that may be tied together with F-links, and that architecture may happen in a large city environment. Maybe in Warsaw, where you have a really large city. In such a dense population, there might be multiple switches, and they're tied together with the SSPs are tied together with F-links. If there's for congestion and for redundancy, you may have what they call E-links or AA links, which are redundant A-links, so that the A-links have redundancy for messaging if needed. And then in the center there, we show C-links, where you may have STPs that are clustered together. And if you have STPs nodes that are clustered together, you would use C-links to tie those together. And then those B-links that we see, those B-links are used to tie, like I mentioned with the BGP, where you have the peering on the global internet, those peering points. With those B-links are used to tie in different telco networks in the SS7. That's how they integrate together, is with B-links. Then a real quick overview of cellular network architecture. Over on the left, we have the base transceiver stations, which is going to be your towers, where our mobile phones, our mobile devices are jumping on different RF channels, and as we roam around, we get on different base transceiver stations, and those base transceiver stations are controlled by the base station controllers that are managing and keeping up with us as we roam across different towers and different networks, and report back up to the mobile switching center. And all of that infrastructure is managed by the operations support subsystem. And think of that operations support subsystem, the OSS, is the NOC, the Network Operations Center, for all of this. That's where the management, the monitoring, the health and status, configuration control is the brains of that operation. And it would also, that OSS would also connect into the business systems of the telco enterprise network. And that's a very target-rich environment from my experience. When you see that OSS, think lots of systems, lots of databases, lots of apps, lots of remote access from vendors where they can get in and help keep the services working. And also where customers, there's going to be trust relationships over to the right, where customers may be interacting and automatically provisioning services from home, possibly to a soft switch web interface. That kind of integration could be happening in there. So there's interesting trust relationships to be audited there and evaluated. And then you get down here in the mobile switching center. And down in the mobile switching center, that's where the real brains of the operation is for your cellular network. And that's where you got your home location register. That service, that system is keeping up with the cell phones that are a part of that cellular network. And then you got the authentication center that is associated with the HLR, and that's where your SIM cards are being authenticated to verify that your phone is good and that's going to authenticate your SIMs. And then you got the visitor location register, and that system is keeping up with users that are roaming around the network. When you leave your network and you're on different say like I'm in the U.S. and I'm over here in Europe, I'm reporting back to the VLR, the visitor location registrar, that I'm not on my home network. I'm not back at the HLR. I'm over here on connected. I'm roaming. So that VLR will keep up with that. And then you got your equipment identity register, and what that's doing is it's going to keep up with stolen phones that may be rogue, that may be lost, etc. And then again, you're getting all of this is going to be integrated and tied in with other telcos based on that architecture we showed previously with with the PSTN. Now, I'm an old school network person, and to me, I'm all about the PCAP. I want to see we can talk all these protocols and acronyms, but I want to see the network. I want to see a PCAP. I want to see what does a packet capture look like. So here's what a packet capture, or really a frame capture, I guess you would say, because there's no, as you'll see in here, there's no IP. We're looking at a frame, and then we drop down into SS7 messages, and down here I got circled here. You can see where right here you got ISDN that's encapsulated in these message transfer part level frames here, and then you can see where we've got a calling number and a called number and the calling number here. So there's no IP. This is all pure dialing and over ISDN here. And this kind of capture would not be happening over Ethernet. You would have to have a specialized test set. Typically in the US, what I'm familiar with is a test set called a T-Bird that will go in and capture frames off of like a E1, E3, T1, T3, where you can capture those frames at that level. And then you can take it and you can import it into a tool like Wireshark or whatever your favorite protocol analyzer is. But I wanted you to see this for reference. Now here's where things are interesting, because we're all a bunch of INFOSEC folks. We want it all on IP where we can ping it and we can target it and we can point Metasploit at it, right? Go hack the world. So here's an example of where you can see you got your frame and you got your Ethernet and we have IP, and then the SS7 is encapsulated in IP. So the world of today and tomorrow, this SS7 network that used to be just a closed, non-IP, not pingable from the world is been brought online. And now we can ping it and we can route to it, and so we can go and put in back doors. We can get access and drop in whatever our favorite tool is for backdooring the network. Whether there's a Pineapple or some kind of 3G, 4G, 5G backdoor device on that network, and be able to, from our laptop anywhere in the world, be able to integrate in with this SS7 network and influence communications, because it's all in IP. So here's where I want to focus and get you to think about is here's an example of what a telecommunications network might look like. I spent 15 years building service providers, telcos, utilities, where the services were all converging together. It was getting hard to tell the difference between a cable company, a phone company, and a utility, except for the utilities provided services like gas, water, and power. That was their differentiator. But they were all going and getting into offering cable TV, voice, and internet services, and Metro Ethernet, et cetera, services to their customers. But they all have a lot of common services. So what you have is you got the video head-in, you got their voice switch, their soft switch, which is basically a lot of times might be a redundant Solaris boxes running whatever vendor app they choose for their Class 5 switch. And you've got different services for monitoring, for billing integration, the middleware. And then, of course, you got your services like lawful intercept, where lawful intercept we talked about yesterday in my workshop. Lawful intercept is where the government can come in and provide a warrant, provide paperwork to telco service provider and say, we want all the traffic for this individual. And so when that is provided, then the telecommunications infrastructure provider will enable a capability so that A and B start talking, a perfect copy is sent to C, and A and B have no idea that a perfect copy of all their communications is being sent to C. That's lawful intercept. And that's used around the world. And you'll see that in all the different vendor infrastructure, both network and voice and other specialized telecommunications will have that capability in the network. And then you go and ease down into the network, and you get down into their core infrastructure, and that's where you're going to have the your MPLS core network, what I call BFRs, big freaking routers. Routers as big as a door. They're basically layer 3 switches with lots of ports, lots of speeds and feeds, or and they're also going to have your optical network, where your DWDM, your SONET in the U.S., SDH in Europe, and other parts of the world. All of that magic is going to be happening here at the core. And then you're going to drop down into the access layer, depending on the provider in the business model. They may be offering active Ethernet, which is basically Ethernet out to the business or the customer home, or passive optical as an architecture. Maybe they're still offering T1, E1, and DSL services in some parts of the world. But the key thing that I want you to get out of this that I've seen is, when you're out there buying services and you're negotiating for your large critical infrastructure organizations, you've got to dig in and ask the hard questions, because here's the thing that people don't know, and they don't want anybody to ask the hard questions about. Majority of these services and solutions are backdoored to high heaven. I have read the contracts. I've been in the rooms when they've been negotiated with providers, and I'm going to show you some examples where they will have remote access. They'll have SSH access. They will have SSL access, some kind of VPN, where they drop in their own routers, they drop in their own firewalls, and totally bypass the infrastructure for, say, the internet guys, the people who are fluent in IP. They understand security risk, and they understand how to go and lock things down. But you get in, like every organization, you get into politics, and you get into revenue streams and business plans, and you have the voice, you have the video, and everybody's got their own empire. They have their own political influence, and they can come in. Their vendors have a lot of power and authority, and they'll come in and totally bypass, in some cases, the security that the people that are fluent in the internet would like to have in place. I've seen them just totally bypass that, and I'm going to go into some examples. So what I call this is everybody talks about the APT. I call this the VPT, the vendor persistent threat. I usually get last with that. so I call it the VPT, the vendor persistent threat, because the vendors are putting in these back doors into these networks where they can get this remote access. And this is what we're going to dive into, of how people can get into the SS7 network. Now, one strategy, if you're a consulting company, or you're involved with auditing critical infrastructure, maybe you work for a big consulting company, or you have associations with government agencies, and you're out doing auditing and evaluating the security of critical infrastructure, or maybe you work for a critical infrastructure vendor, and you're looking at things. Here's a pen testing. Here's how I like to look at networks. I like to go in and do all my recon, get all my intel, find out all the open source information. Because one thing that you'll learn about in the telecom industry is everybody really brags a lot about what they bought and purchased, and likes to get their name put out there in press releases that they implemented XYZ's routers, XYZ's SAW switches or cable TV head-in, and they put all that information out there. And then it makes it real easy to go and figure out what vendors you need to go find out who the field engineers are that may be working on site, and have a laptop with everybody's infrastructure information, with everybody's static passwords and username passwords, so you know who to go after. If you're a hacker, unauthorized hacker, a black hat, you would know who to go target, so you could piggyback off their laptop to go in and exploit the trust relationships to get in these networks. So you're going in and looking at that network management, the billing system, the middleware that's tying the billing system to the provisioning for the network. You can go and figure out, reverse engineer how the vendors do remote access, because one thing they're consistent around the world. If you can get in the head of a vendor and field engineers of how they access these networks, you can go and get into all of them across the world, because they're consistent. If they do SSH in Europe, they're doing SSH probably in US. And when I say SSH, I'm talking about wide open, brute force it until you get in SSH access. Totally wide open, no account lockout, real simple to guess passwords. And so you figure out those trust relationships, between those vendors, and then develop yourself an attack tree, and then you're most likely you're going to find a way into the network. You're going to find some vulnerabilities and some access into the network if you do a good job here. So here's a real world example. I like to go into and use real world examples minus the guilty to protect myself and protect them obviously, but most importantly to protect me. This is some real world stories here. I've seen this numerous times. What will happen is we have in the middle of the network here, we have a transport network, and this is the speeds and feeds, the backbone of a utility, telco service provider. This is, the optical network, the TDM, the telecommunications, the infrastructure where they're provisioning E1s, T1s, E3s, T3s. All of that is, gigabit Ethernet. All of that is being provisioned across this transport network here. And across those services, they may have, their voice network here, their SS7, their soft switch services, their cable TV, all of that infrastructure all those services are going to run across this. And what I've seen for both the transport network and for these voice networks, I've seen this in multiple cases around the world, is where the vendors dropped in Linux boxes, multi-homed, one leg into the network management portion of these networks, the secure, air gap. How many times, that's one of the most abused terms in networking and INFOSEC and IT in general is air gap. So these air gap network management networks, and what they do is they'll drop in a Linux box with one leg into the management for, say, the voice network or for this transport network, and then they'll have another leg, the second Ethernet connection that totally bypasses the security that the IT folks put in, that maybe the internet service provider folks put in, who really understand how IP technologies work. They understand store, and they understand how to configure a Juniper, Cisco firewall, what have you. These voice guys don't, and these vendors will go in and drop these boxes in with an open SSH service, so that when they're out on the road, what have you, and the customer has a problem, the field engineer can go and come back in and help and support them. And what happens is, I've discovered, is they drop these Linux boxes in, multi-home, wide open to the world, and they end up getting hacked to high heaven, and their IDS is typically a bank somewhere in the world calling them to tell them that their networks got popped and is being used to attack their bank. Please cease and desist. And it just amazes me. In many of these cases, the people who have hacked these networks don't realize what they've gotten access to, because what they've done is they've gotten access to what they call the EMS, the Element Management System. And think of Element Management System as the network management system like SolarWinds, HP OpenView. The equivalent for these specialized equipment, it might be the voice switch, it might be the optical gear, it might be the TDM gear, the sonic gear, or the router vendor that's providing the MPLS transport services. And when you get into a specialized vendor, they call it an EMS, an element management. And that EMS, they'll literally drop that box in with multi-homes. My head just wants to explode when because I'll get the call somewhere, hey, we've been hacked, we're getting letters and calls to stop hacking, and you go and dig in. I'm like, oh my goodness, who did this? You literally spend, $500,000 on security infrastructure, and you just totally bypassed it with a patch cable. It's like, you just can't fix some things. Can't fix politics, right? So here's another example. Pretty detailed example of a telco, what you have, of how a telco might get hacked and someone get access into the SS7 network, similar to what we just showed. The whole point is how can we get access into that SS7 network? How does it go down real world? Well, here's a more detailed diagram, and all these slides are being provided to the conference, so you can go and study them offline. So you have a network operation where the brains of the operation is. All the blinky lights are being monitored and managed. You got all the vendors' network management systems, monitoring and provisioning, automated, doing health and status of the network, bringing new user services online, and all of that brains and intel is happening here, and it's integrated over to the OSS, as we showed on one of the first slides, which is also going to be tied in to have the trust relationships over to the enterprise, where there's business systems and accounting, built in, the billing information, maybe user provisioning, so that the end customers can automatically provision new services. There's going to be trust relationships into there. That opens up a whole nother set of opportunities. If that hasn't been secured, and again, they got the VPT over there, the vendors that want that remote access into all that infrastructure. And so it comes down, and you have those trust relationships into your core infrastructure, as we just discussed. And you got your voice services, you've got your data services, and your GSM, 3G, 4G, 5G services that are going to be relying on these transport networks. But what I want to call you out to is maybe they're doing MPLS, maybe they got some legacy frame relay still out there, what have you. But I had a personal experience where a customer, they had a very large wide area network, a huge network, like 60-something sites, and they went from one carrier, migrated from one carrier to a second carrier. And as we had to transition from the first carrier to the second carrier, we had to buy all brand new infrastructure to get during this migration, this transition. So the first carrier, every time we would go and cut a site over from the first telco to the second telco, and dropping in new router equipment, it turned out that the first telco vendor, the incumbent that was being migrated off of, they just abandoned all their equipment in place. And so we ended up, the customer cut over all their sites, and then through mergers and acquisitions, over doubled in size. The customer's like, hey, the first telco abandoned all this equipment. We're not going to buy all new routers, because all we're using is 64K and 128K connections for IBM green screens, back to mainframe type stuff. We don't need high-speed routers. We're just going to use this old stuff. They started doing recovery on these routers and discover like all of the brains of the operations, because they just threw it away. Somebody made a decision in a spreadsheet that it wasn't good economics to go and pull all that equipment back. Well, what did they leave? They left routers out there in place with all the passwords, all the routing policies, all the SNMP community strings, how the trust relationships with the network operations center, the information on the boxes that are collecting net flow, the syslog servers, all of that intel just left out there. I'm like, oh my God. Just left all that out there, and that's and you can only imagine all that same equipment around the world is showing up on like eBay and being sold, refurb, and people are getting access to this stuff. So that's another example of how people can find their ways into the telco, because this stuff is just getting out there pushed. Some project managers abandoning all this equipment with all of that intel and not bringing it back and having it destroyed properly. And so you get that access, you get all this intel. Now you can revert based on what you've got from a remote site where the telco service provider is providing managed services. How much, the cloud, it's going to be secure because it's the cloud, right? So they got a cloud-based service, and they got equipment out there at the customer prem, and it's got all this information with all this juicy information with trust relationships. So now you can reverse engineer how this cloud up here may work, the NOC may actually work, and then all you have to do is go over to LinkedIn and find out who your good targets are, and figure out how you're going to pop them and piggyback in if you don't even go direct through their internet connection, maybe through phishing an email directly into the company. Me, if I was a black hat, I'd probably just go after the user and try to figure out who their family members are and target their spouse on Facebook or Instagram. Go through some social media service and find a way to piggyback on their network connection back in to the network. Just one thought. But anyway, this is a one strategy that could get someone into a telco network possibly. No, so we've got into the telco. We've covered a couple ways that someone might break into the telco. What are they going to do? How are things going to go down once they've gotten access into that voice SS7 network and they got that initial handhold here? Well, if they're wanting to go and target the mobile phone subscribers, one thing they're going to need to get the MC code for that subscriber. And the MC code for the phone is a unique identifier that all the phones have that uniquely identify you on the cell phone network. So one thing they're going to need to do is they might have your phone number. They may know the STP point code. They figured that out through their intel, but they need that MC code for that phone. And so what you can do is if they have this access, they can craft messages and impersonate a SMS center and send a message up to the home location registrar for that phone number that they want to target, and then that home location registrar would respond back. It would go and say, query the visitor location register information, and it would figure out where everything is at, where the user is at, and it would return back to the attacker all of the information they requested. Give them not only now is he going to have the phone number, he's going to have the MC code, he's going to know the visitor location register so that he can go and figure out where he's roaming at, etc. And now we can start targeting this mobile user. Now there's one feature in SS7 that is being locked down, the trend based on my research. The trend is this feature is being locked down and taken away from the attack surface, but it's still out there in some parts of the world. Like every feature, nothing is 100% locked down. It's like when everybody's shutting down XP, but there's some people that are still running XP. Same thing with this anytime interrogation feature in SS7. And what could happen is the attacker that has gotten access to this SS7 network can go and send a query into the home location registrar and exploit the anytime interrogation feature, send up a crafted packet to the home location registrar, and then it will go and query the visitor location registrar and find out where that mobile user is, where that mobile phone, that mobile access device is somewhere in the world. And when it finds out what visitor location registrar that is located on, what it's using, like say if they were targeting me, they would go and hit my HLR, my home location registrar back in the U.S., and then find the VLR that I've reported to, and they would go and then go and hit the local tower that I'm on, and then it would report back to the attacker, hey, he's over in Gdynia this week, and then it would bring that information back. But this anytime interrogation, like I said, is that attack surface is slowly going away, according to the research I've done. They're shutting that down. But there's always other vulnerabilities, right? Like you close one door and there's always others that are open and just waiting to be discovered that haven't been locked down yet. So similarly, we've still got our access here by whatever means, whatever attack path we've come up with, and we start crafting packets. We can impersonate a home location registrar. Say somebody wants to target me, say someone, say in Asia, wants to target me, they could impersonate my home location registrar and send in a request and find out that, and send it into the SS7 network and find out that I'm over here in Poland and find out the visitor location registrar I'm on, because my home location registrar will report it back. They'll go and hit this VLR, and it'll go out here and query and find the tower that I'm on and find the geographic region that I'm reporting back to and send that back to the attacker that is basically impersonating another MSC somewhere in the world. And then they would know where I'm located at. They could find me if that was their goal. Now, what really got me interested, what I started wanting to do this project for and do this research and understand this better, was being able to do man-in-the-middle attacks. And so here's how. This is just like we can, we could do man-in-the-middle attacks off of local Ethernet. We can do man-in-the-middle attacks, say with and I talk about a lot in my previous talks about being able to do man-in-the-middle talks both at the local level with routing protocols inside the enterprise or with BGP on the global internet. Well, we can do the same thing with SS7. We can do a man-in-the-middle attack. So we've gotten access into the PSTN here onto the SS7 through some telcos SS7 access that we've exploited. We can we can go and we can impersonate a mobile switching center. We can impersonate the cellular network here, and send up queries. Well, actually not a query, but an update to the home location registrar, and tell the home location registrar, hey, here's where we are now. I'm actually in Poland, but no, I'm in New Zealand. He's actually moved to New Zealand. He's no longer in Poland, he's in New Zealand, and starts sending updates, just like you would, like, say, the concept like with ARP poison, where you're sitting there poisoning the ARP table. Well, we could go and poison the cell phone network, poison the VLR, the home location registrar. We could go and poison this HLR and say, hey, anybody looking for me? Send them over the SS7 network to this central office, this part of the SS7 network down in New Zealand. And I'm sitting in Poland this week. And what would happen is they could have those calls, then redirect anybody that sends me calls or text messages, could have that redirected, to the most southern parts of the world, and redirect my calls. And then they could either capture it, depending on the platform that they've got set up. They could either just capture my messages in the initial call setup, or they could forward it on. And me, I want to go and forward it all the way on, and then you could totally intercept the phone call, you could intercept the text messages, and the endpoint. I could be sitting here in Poland and not know, outside of the delay of, say, a voice call, maybe having the delay in the voice, possibly, because you can't fake time. You can impersonate and fake a lot of things, but you can't fake physics. Physics is physics. You can't, speed of light and time, you can't mess with. So we could go in and reroute calls and messages and intercept anywhere in the world. Some things to consider, some tools. For y'all that are consultants and auditors, pen testers, red teamers out there, there's a couple tools for testing SS7. There's this SIGploit. It's on GitHub. The team at ERNW, they developed a tool called SS7 Mapper. If you're not familiar with ERNW and you're interested in telecommunications, I cannot encourage you strongly enough to go and check out the papers and blogs that the ERNW team have. They're really, really strong in telecommunications and networking. They're where I get a lot of inspiration from and a lot of ideas from the ERNW team. Really, really sharp engineers. Also, if you find yourself working in the telco service provider world, there are firewalls for SS7. I spent 15 years working in that domain, and I can tell you, I never had a conversation with a voice company about a voice firewall. I was selling firewalls to protect the enterprise side of the network, we were protecting the video side, the internet side, but I ain't never had a conversation about the voice side. But here's some firewall recommendations. And if you're out there auditing, I would treat some of these networks. Some of these networks have not been patched and updated because it's kind of like a lights out. You get it working and nobody touches it until somebody retires. You just get it working and nobody touches it unless the vendor tells them to and approves it. So if you're out there testing, don't go plop in with your Metasploit and your Nmap and your Nessus and just go scanning. You may want to go make sure that these systems are somewhat patched, are not going to crash and roll over and have a panic attack when you go and start hitting it with malformed packets and things. In case you're dealing with some old legacy stuff, so be careful there. And like I said, I showed you could do man in the middle against your SMS. So you need to go and relook at alternatives to SMS two-factor authentication because it can be broken into. And similarly, I spent over 15 years working with telco service providers. And not only did we not have many conversations about firewalls for the voice side of the network, we didn't talk about what I call SVI, Secure Visualization Instrumentation, getting the net flow, getting the network monitoring, getting that visibility that we all work real hard, like the Splunk, et cetera, on that, work on getting that in that voice network. So especially you folks that are into consulting, this is something they go target. I think there's some good business out there that our peers have not gone and chased in the critical infrastructure world. I got lots of references, lots of pages of references. I that I use to get this information and learn this. And like I said, you can have the slides. The slides are provided to the conference if you want to dig into all those references and things. If you have any questions, you can always contact me on LinkedIn or Twitter.